So today I wanted to talk about development stages when you're creating a feature and basically try to lead you through how generally looks like when you are just trying to make something work. So you don't care how optimized it is or the structure, you just want to make something work. Then how you can make it good, whatever that means, and then how you can actually optimize it to squeeze out any performance that you can from it. So let's start first by making something just work. So let's say you want to create a health for the character and you want to have a widget that shows the health and you want to update that widget so you can see the health. And maybe you're new, you don't know if this can even work, you never did it. So let's first start from the character. Let's add a variable, let's name it health. Let's set it to float. And now I'm just gonna create a widget. We can do name it whatever, doesn't matter. Let's create a canvas and let's create text. And I'm just gonna move these texts around just so we can see it better. So we're gonna need it as a variable and we need it here. Let's do position 0 and let's do 0.5 here. We can also do size to content if you want. And let's make the font maybe 36 or something. And I'm gonna also move it down. So I'm gonna do 100 here. Now that we have that, we need to just make it show in the character. We're gonna create the widget when the game starts. And this is, by the way, just a default represent template, nothing crazy. Let's find the health widget and let's add it to viewport. So I'm basically doing minimal things that we need to do to just show in the viewport, basically. And let's also do something like this. So let's say you want to update the health and you know that there exists this bind option. So you create a binding for the text and we can do get player character cast to third person. So we basically have to get the value. So we're casting and we can do get health. And there is also a little conversion there. Okay, so let's play and see if everything works. So we press play and we can see our health is 0. So let's change that. I'm gonna go to third person character and let's put it to 100. And we can see our health is updating. Now, another thing that I'm gonna do before we continue is do something like this. So I have this plugin that is called Micro Benchmark, which basically just gets a function and tries to test it and see how much performance it takes to run. So what we can do is health widget and let's get self and let's do on construct instead of pre-construct, and though there is not much difference there. And now let's get text also. For the text, we cannot make it pure. So let's go back and then get text. And let's play again. And I'm gonna stop it. So the reason why we played it again is because I wanted to get info for the micro benchmark. It's basically not gonna run on construct. It's gonna run this benchmark function and basically gonna calculate how long it took to run that function. So now let's type in here micro benchmark. And we can see it 0.40 and then 11 seconds of time. So pretty fast, nothing crazy. We can do this multiple times, see generally what we get. So around 11 to 12, pretty nice. Now we made it work, but here is a scary thing. If you don't know exactly what your code is doing, you're not gonna know that, for example, this get text, if I do print in here, so let's do something like this, and we press play, so that this bind that we created actually runs this code, whatever your frame rate is. I think right now we're around 100 FPS. So let's do show frame rate. So we are basically running this 100 and something times every second to check our health. But our health is not changing. So we are basically wasting a bunch of performance or a bunch of unnecessary ticks tracking our health. Even though the cost is not that crazy. Now the cost increased a little bit because we have print in here. So print increases the cost. But even without print, just running this 100 times a second, you can imagine for, let's say, just 1 minute you're running it like 4 or 5,000 times, it gets really unperformant. And you can imagine in your code if you had, I don't know, 3, 4, 5, 6 of these binds on different stuff. So you have your stamina, health, maybe ammo count. You just have all your things in your UI and you're running this and you're just wasting performance. Now that we went from just making it work, now let's actually make it good, increase the quality of the thing that we did. So when I think about this, how I can go to this stage, I always think about what is the minimal thing I need to do to make this work. And ideally for this, what I want to do is just basically to update this health when my health changes. So I don't actually want to run it every tick on bind and just change it continually. There is stuff that you can do on bind. For example, your game has a timer and timer is constantly ticking and you need every tick to update the time. for the player, you would use bind. But also if you have, let's say, a timer that only counts seconds, you wouldn't do the bind because then you're wasting a bunch of performance. To optimize it more, what we will do is when this patches, and we can do health update, something like that. Then what we can do is plus in here, we can do float and we can do health. And for example, let's say one event that changes our health is when you press 1 on the keyboard. And I'm also going to create a function that is health change. I'm not going to do anything crazy in here. You can imagine a million ways that you can set your health. What I'm just going to do is set my health, and I'm going to do -5, and I'm going to call our health update. And what event dispatchers are, if you never use them, is basically an event that when it is called, it's going to call everyone that is attached to it, meaning it's going to signal this event. You can imagine it as any other event, but there is other events that can be attached to it. And then when this one triggers, it says to other ones to also trigger. So that's the general idea. So even multiple things can attach to the same thing. So we're going to pass our health, and then we're going to get our health widget. And what we're going to do in here, we can disconnect this for now. We're just going to move it to the side, and we're going to get this code on event construct, and we're going to do health update. So now we basically attach to this event to the health update event. So when the health update is activated, this health update event is activated. And they are separate events, if that makes sense. So when this widget starts, it's going to connect to our health, and then our health is going to update. And in here, all we need to do is get our text block, and we can do set text and just connect it in here. And the last thing that we need to do is just call our health change when you press 1. Let's press play. And I'm pressing 1, and you can see my health is changing. So now we are not doing anything when our health is not changing. We are not ticking 100 times a second, stuff like that. There is almost no game that you need to continually change health on every tick. Even if it's a high-paced game, you're maybe going to change health every second, 2 seconds. And just to compare it to what we had before, even in a high-paced game where you change health really frequently, it's still going to be 100 to 200 times cheaper to do it this way than the other way where we bind. So even in the best case scenario for the bind, this is still going to be way cheaper. So now we made the code higher quality, basically. Now the third thing that we need to do to the code is optimize it. Now blueprints are a little bit more high level than the typical programming language. So for this specifically, we really don't have a lot of optimization that we can do here. There is nothing much that we can do because we are doing minimal things. But for example, let's say we were using bind for some reason. We're still using this. And yeah, I actually forgot to remove binding. That was still ticking in the background. And because it was ticking in the background, I think if we test now, if I press play, you can see how it says text block. That's because the health never updates. So let me go back and call this health change. Or we don't even have to do that. We can do health update call in here and just get the health. So we just need an initial update because we don't have that. Now when you press 1, we get the same thing basically. So yeah, let's say now we still want what we had previously, which was, let's say for some reason we are using bind, but we are trying to optimize it. So I'm going to bring it back. I'm going to create binding. Let's get player character, cast to third person, same thing, get health. Connect it here. So we have the same thing. So let's say we have this, but we want to optimize. So if you remember before when we were testing it, we had some low numbers. We can actually check it in here. So this is our numbers previously. So let's try to optimize it. What I'm going to do is disconnect this. So let's say we don't want to use this. We want to use bind, but we want to optimize it a bit. I'm going to save the third person character. So a good way to try to optimize stuff is usually caching, or you try to batch, do stuff together. So we were gonna basically cache and save our third person character so we don't have to cast every time. And now what we're gonna do in here is get our third person character, get health, connect it in here, and then remove this. And we can delete this old one, so we have only the new bind. And also let's after this test and see how it goes. Also for the new bind, we need to set it on pure so we can see it in here. Now that we can see it in here, let's click to that function and let's connect it here. Let's click compile save, and I'm gonna clear everything. Let's do benchmark. Let's press play. And now if you press multiple times, you can see it is a little bit lower because we're not casting. For some reason it was a little bit higher in the beginning, but we can get 9 or 10 usually. which is not too bad. So basically we decreased it by maybe like 15-20%, which in Blueprints is fine for an optimization. Since we are doing really simple things here, there is nothing much more that I can optimize. But you can imagine if you have more complex system, there's gonna be a bunch of small ways that you can try and optimize stuff. For example, making something thread safe is a good way to optimize, because then you basically activate all of your cores to do a thing, or whichever core is available. So yeah, stuff like that. But in here, the only optimization we can do is basically just use the casting. And if you think instead of casting, I can use interfaces to avoid casting, the issue with that is that interfaces are actually, so let me show you. Let's create an interface. I'm going to quickly create, I don't know, health get, let's say. We can do float, health, add it in here. We need interface here. We get the health, connect it here. If we, for example, do something like this, and what we'll do is instead of this, what we'll do is get health and basically get it from the player character, let's say. We can do something like this, and then we don't have to do this. We can jump directly to the test. Something like this, and let's press play. You can see how now it gets even more expensive. And the reason for that is that interfaces are actually, or interface calls are actually usually a little bit more expensive than costs. So if you're thinking I'm going to use interfaces to optimize something, that's not going to happen most of the time. So interfaces I almost exclusively use only for decoupling stuff. It's good for that. But everything else for optimization is usually not good. So yeah, we have 3 stages: make it work, make it good, and optimize it. Now I'm gonna go into advice mode and tell you basically what I think about how you should try to work. Ideally, by default, if we imagine this is the 3 modes, ideally you would always be somewhere in here. Optimizing can sometimes slow you down a lot, especially since most of the things do not necessarily need to optimize. And when I say optimize, I mean you go into the nitty-gritty, you try to do like the smallest thing to pull out performance. There is some things that you need to be careful about and leave in this area. Maybe you're creating like navigation system or something, and there is going to be a lot of, I don't know, raycasting, for loop, something. There is something going to be happening that is intensive, so you probably want to be on more careful side. But if you're just in this area here, you're probably going to be in a better spot than I would say 90% of Unreal developers, just because I think most people operate in this area here. So basically, they just try to make it work, and when it starts working, they go to the next thing. And what I want you to do is basically try to make this your default. So however you're making the code, you're generally in here. And when you do that, your project structure and stuff like that is going to be way better. So for example, instead of doing the binding thing and then going to the next thing, and then maybe a month or 2 or 3 later, I try to go back and make it good. If it's like a big structural thing, it's probably not going to happen. I'm just going to leave it as is, and I'm going to take the performance hit. Changing structural stuff, like I have a bunch of bindings and I didn't think about event dispatchers, so my whole structure is not created for that, so I'm going to have to break a bunch of stuff down to try to make it work. That's probably not going to work, so you don't want to do that. This can be good for really quick prototyping, but even when I'm prototyping, I'm usually in like this area, maybe somewhere in here. And the reason for that is that if I like whatever I'm prototyping, I have really easy time to just go in here. And if I make my code this quality, I'm in a good spot basically. So yeah, I see a lot of people living in here where they just make it work and don't think about how can they make it good. And what I would say is, when you're thinking about anything that you want to implement, think about what is the least amount of work that this thing needs to do, or least calculations that needs to perform to do particular action that I want, that will make me satisfied that this feature is implemented. So for example, for health, for updating the UI, I just wanted to update when I actually change the health. I'm going to be completely satisfied when that happens. If you conceptually try to think about that, wherever we change the health, we then need to let the widget know you also need to update. Instead of widget asking all the time, hey, are you updated? Hey, the health change, let me update the health, stuff like that. You can inverse it and basically send it from wherever you have the health. Now, why I say think about it conceptually is, even if you are new to Blueprints or new to Unreal and you don't have many tools in the editor to do whatever you want to do. If you think about something conceptually, you're gonna think about how you want something to work, and then you're gonna go research and see how you can do it in Unreal basically. And there is probably some way to do it. So for example, if you only know about bindings for the text, you can just think about, hey, I maybe want to have, I don't know, you're familiar with timers, so you say, okay, maybe I'm gonna use a timer and I'm gonna track if the health is changed or update the health once every 10, I don't know, 10 frames or 10 times a second or something like that. And that's gonna be frequent enough where the player is not even gonna notice that I'm not updating the health every frame, and you're gonna be satisfied with that. And that also is not too bad of a solution, because it would be way cheaper than debinding, because binding does it 100 times a second, but if you do the timer with 1/10 of a second, you're 10 times better. So even that is a better solution. So even if you don't know Unreal much, you can just conceptually think how you can make this work, and then try to Google around, see forums, stuff like that, and see how other people did it basically. You don't have to constrain yourself to whatever you know in Unreal, just think generally. And ideally for something like this, the event dispatchers are going to pop up, and they're pretty useful for this specifically. So hopefully this helped you. I try to build my habits of how I build my code to be always in the second category, so make it good. Whatever code I make usually is like a 7 out of 10 code. It can be optimized to be 8 out of 10, 9 out of 10, but it is not necessary. It's still pretty good, and I never want to fall into creating a really scrappy prototype code and then leaving it in the project, because it gets messy and your performance is going to suffer. And your performance is going to suffer over time. So what's going to happen is you're going to implement a bunch of features, and one individual thing, like one binding that you do in here, is not a big deal. We all have decent computers, we all have gigahertz and multi-cores and whatever. So all of this is not that big of a deal, but it's the death of 1,000 cuts. What's going to happen is you're going to have 20 bindings, you're not going to care about if you're doing a bunch of stuff on tick, and you're just going to notice that you have 5 enemies in the scene and 30 FPS for some reason. So you don't want to ever get into this situation. Just need to make your code good enough, and later if you need to optimize, you can jump on a few places and fix it. You never want to have just like a really scrappy prototype code. And if you keep yourself to higher standard to always create a decent code, you're gonna have way better time and way more opportunities. Because if you think about performance, kind of goes hand to hand with possibilities. Because let's say with perfectly optimized code, you can do this, whatever this is. And the more you push unoptimized code, bad code, scrappy code, prototype code, this kind of bubble of possibilities shortens. Meaning, let's say you want to create a game with 100 enemies, player is fighting zombies, and you want to have 100 AIs running around. If you did not think about performance of your code, what's going to happen is you're going to put 10 or 20 AIs in your scene, and it's going to lag, and you're going to continue making your game, and it's never going to happen that you implemented another feature and now your game magically runs faster. Every time you add new code, it's going to be a little bit slower. So if it's slow with 10 or 20 enemies, adding new stuff is going to make it even slower. So the only way to add a feature and increase the FPS is to add a feature that optimizes the things that are already there or something. But in 99% of the cases, you add a new thing, that new thing is now going to make your game slower. At the end, you're maybe going to have 5 zombies and it's going to be like 40 FPS or something. You always want to think about performance, because you don't want to just magically take all of your performance away on some dumb things like bindings, which is just going to take like thousands of ticks every minute to basically do nothing. So yeah, make your code good. It's going to be easier to optimize, work with. Performance is going to be better. You're going to be happier. Good things are going to come to you. So yeah, hopefully this helped.